Okay, today we're going to do a short review on exponents. So if I look at 4 raised to the second power, let's break that up into parts. So if I were to look at my 2, that's going to be called my exponent, just a little number, okay? And then that big 4 is going to be called my base. Okay, whatever's the bigger number, think bigger B for base, smaller number, exponent. So if I were to talk about the form of exponentials, exponential form is what you see here. You see the exponent, so you have 4 squared. Okay, expanded form means what does that actually mean? 4 squared actually means 4 times 4, right? Instead of multiplication. It's just saying 4 times itself 2 times. And then standard form is evaluate 4 times 4, which is 16. Okay, so I have exponential form where you see the exponent, expanded form where you actually show the multiplication, standard form, evaluate. Okay, so now what if I gave you, let's say, 3 times 3 times 3, right? And I want you to tell me what the exponential form was. So my base is 3 because that's what I'm multiplying every time. And how many times do I multiply it? 1, 2, and 3. So I would have 3 to the third power, or 3 cubed. Now let's evaluate that. 3 times 3 is 9, times 3 is 27. Awesome. So those are the different types of forms. Now what if I gave you, let's say, a standard form of 49? Now let's think here. What times itself, or times itself, could be 49. Well, I know that 49 is a perfect square, so 7 times 7 would give you 49, right? So if I were to write that in exponential form, 7 would be my base. I times it twice, by itself twice, excuse me, and that would be 7 squared. Awesome. Let's try, I don't know. Let's try 121. So same thing, 121 is perfect square. So what times itself is going to be 121? That's 11 times 11, and that's going to be 11 squared. Okay, so those are just different types of forms of different types of exponents. Okay, awesome. So now, what if I have a 0 power? What is 2 raised to the 0 power, or anything raised to the 0 power? Well, let's test this out. So if I have 2 cubed, what is 2 cubed? 2 cubed is actually 8, right? It's 2 times 2, which is 4 times 2, which is 8. What's 2 squared? 2 squared is 4, okay? 2 to the first power is 2. So then what is 2 to the 0 power? Well, let's see the pattern. How do I get from an 8 to a 4? Okay, yeah, I subtract 2, but think multiplication, division. I'm going to divide by 2 or multiply it by 1/2. Let's just say divide by 2, right? Okay, what about 4 to 2? Same thing, I'm going to divide by 2 or multiply by 1/2. Okay, so now if I were to go from 2 to the first power to 2 to the 0 power, all I have to do is take 2 and divide it by 2. 2 divided by 2 is actually what? 1. Okay, so 2 to the 0 power is 1. And that already is true for anything raised to the 0 power. So you could store this and just say anything raised to the 0 power equals, whoa, that's incorrect, equals 1. Okay, awesome. Okay, now, if I were to go a little bit further and understand bases. So what's the difference between my left and my right exponential forms? The obvious difference is my parentheses. Okay, so if you're looking at the parentheses, that's what establishes the base. So actually, to the left, this is saying minus the value of 4 squared. So this is saying minus the value of 4 squared, which is 16. So that's actually negative 16. Okay. When I establish the base with parentheses, that's actually saying the base is negative 4. So I'm going to multiply negative 4 by itself. Negative times a negative is a positive. 4 times 4 is 16. So the difference here is that if I don't have the parentheses, then I'm just going to take the sign whatever's in front. If I do have a parentheses, that I have to use that sign when I multiply it by itself. Okay? Now at the bottom of your page, if you could just write 4x squared. Okay, now I want to talk about like bases. We talked about like terms, now let's talk about like bases. So now your base is always what's being raised to the exponent. So in this case, my base would be x. My exponent would be 2. What's the number in front? That's called the coefficient. Okay, awesome. So now I want to have a like base. So it doesn't matter what number's in front or what the exponent is. It's a little bit different than like terms. Like bases is anything that has an x, really. So if I were to talk about like bases, let me actually move that. Okay, so if I were to talk about like bases, it's anything that ends in that has an x as a base. So if I have 4x squared, okay, I could have x. I could have 2x to the 3rd power. I could have 4x to the 5th power. I could have x to the 7th power. Negative 10x to the 6th power. Anything that has an x as the base of the exponent, okay, is going to be a like base. Okay, so that's all we're going to be discussing for our exponent review. And I'll see you next time. Thanks.